Welcome everyone. So in this session we are going to solve a DSA problem, that is a kind of an optimization problem. So as you can see, the title itself suggests to minimize a particular function. So let's try to see what is the function we are trying to minimize here. So minimize a function, and the function is nothing but maximum between a triplet minus minimum among the same triplets. So let's try to understand what are these triplets corresponds to. This A I B J C K is nothing but any element that corresponding to an array ARR1. For BJ is like any element corresponding to ARR of 2. CK is nothing but any element corresponding to ARR of 3. Similarly, this things also, the other part of the function. And you want to select any of these numbers like AI, BJ, CK, such that it can be any combination, such that this particular function has to be the minimum. That's what we need to find. How can we find out that? And one more information given here is that all these arrays given here are sorted. That means the numbers are arranged in ascending order, in an increasing fashion. So this much information is given. And how we are going to find out? So the brute force method is nothing but generate all the combinations of I, J, K. For example, fix I and J at the initial location, then vary K. Then change J to the next location. Now I and J is again fixed, then again vary K. Like that we can generate all the possible combination of triplets, and we can record each and every value of this particular function, that is max minus min, among the chosen triplet combinations. And out of that, whatever be the minimum, we just have to return that. So if you going to approach that particular way, this is nothing but one loop in which I is going from 0 to n, 0 to n, I is going from 0 to n, and j will be also going from 0 to, here is m, 0 to n, and k will be going from 0 to k. So it's like back to back 3 loops. And what is going to be the time complexity? In this case, the time complexity would be of the order of m times n times k. Space complexity would be order of 1. I am not going to code it, so it is very trivial thing. Just need to calculate and store it. And this is of high time complexity. So can we optimize it? Yes, we can optimize it, because there is one more information which was provided, that all the array is sorted. We need to make use of this particular information. So before that, let's try to take a moment and try to see what really we are going to optimize it. So I am going to erase the explanation part for the brute force, and let's try to understand what are we going to minimize. Minimize something. And what is this something? This something is nothing but maximum among a particular combination of triplet minus minimum among the same combinations of triplet. I am going to call this entire thing as range. And one question is that initially we have fixed the pointer I, J, K at the 0th indices of the corresponding arrays. And since it's fixed at the 0th indices, the natural thing we can do with these pointers is to move right. So when it moves to the right, that much freedom we have, that much degree of freedom we have towards the pointer. When we move it towards the right, how each component of this particular range, like max among ABC and min among ABC, is going to get affected, and what trend we are expecting such that the entire range thing is going to get lesser and lesser. If the range has to get a lesser, the first component max among ABC has to decrease, or the second component minimum among ABC has to increase. Because if you consider these two components separately, this is nothing but x minus y. Either x should decrease or y should increase. And the question is, what is going to happen when a pointer we have decided to move from left to right? So you can see when it going from left to right, this value is going to get increased, and this particular component, because of that particular movement of any pointer from left to right, either it will not going to change or it might increase. That is not what we want. But on the other hand, the minimum among A, B, C, in that thing, either this is going to stay as the same thing, or it might increase. It might increase. If this increase, this will contribute to lessening this particular range. So that can happen. And the question or the approach should be is that we can iterate I, j, k, everything together, and whatever be the value, for example, if A is the value corresponding to I index and B is the value corresponding to J index and C is the value corresponding to K index, and whatever be the value minimum among all these three, that particular indices we can advance one step ahead, so that we don't need to generate all of these combinations of the triplets. It will eventually allow us to arrive at our solution way faster. This is an intuition behind this particular approach. Understanding what the component of this range. You will understand more clearly when we started to code it. So let's try to code it. So I am going to make space for coding. So this is the method. Define min diff. I'm going to give name as this. And what are the arguments? ARR1 is given, ARR2 is given, ARR3 is given. And I just need 3 pointers, I, j, k, all fixed to 0. And I just need to return the minimum difference. Initially, I am going to fix to infinity. And the way in Python it's done is like float inf. Now let's try to move the pointers. While I less than length of ARR1 and j less than length of ARR of 2 and k less than length of ARR of 3. And here we are going to find one thing. First thing we are going to find is nothing but find this maximum component and find this minimum component. Then let's upgrade this min difference on comparison between existing min different and max minus min. Then we can think about how, in what direction this pointer can be moved. So let's calculate the components individually. Max value is nothing but maximum among ARR1 of I, ARR of 2 of j, ARR of 3 of k. And min value is nothing but minimum among the same 3 triplets, just need to copy it, just need to write that thing here, same thing, it is minimum, and then update the min difference. Min difference is nothing but minimum among the existing min difference and max value minus min value. Now we can think about how can we move the pointer. If min value equal to ARR of 1 of I, if this is the case, then we can move the I pointer, I plus equal to 1. If min value equal to ARR of 2j, here we can move j pointer, and obviously the remaining else would be k plus equal to 1. Like that we are going to arrive at that particular combination of triplet very fast than individually checking all the possible triplets. And once this is while loop is exhausted, we just need to return the min difference. So what is the time complexity in this particular case? The time complexity is nothing but of the order of m times, it's not m times, it's an addition, because everything happened here, either this exhausted or this, either I exhausted or j exhausted or k exhausted, that's the thing. So time complexity is nothing but of the order of m plus n plus k. Space complexity is order of 1. So this is an intuitively rich problem to understand. Like it's an optimization problem, and this is how we have efficiently approached this particular problem. I hope you understood the solution for this particular problem, and thank you for listening. Now that's it for the